All right, functional groups. So this is page 441. Make sure you've got that sticky noted. So I'm just going to write a few little notes here. Alkanes, alkenes, alkynes. Okay. Double bonds, reactive. So the alkenes are much more reactive than the alkanes. Okay, and the alkynes are much more reactive than the alkenes. Alcohols, so you've got that OH functional group there. So whenever you see that OH group, you need to start thinking primary, secondary, tertiary alcohols, and we'll have a look at balancing some of those equations in just a moment. Remember, the test for alcohols is the sodium test. So if we add some sodium into alcohol, we'll get some bubbles of gas forming, hydrogen gas forming. Remember, we need the alcohol dry. So before that, we add some calcium chloride, something like that, to dry the alcohol. Okay, want it nice and dry because otherwise the sodium will react with the water and not the alcohol. Might go back up here. Your alkane test, because they're so reactive, we use bromine gas. Brown gas, we make, then we split them, we split that double bond, and we actually add the bromine to the carbon chain where the double bond would be. All right, alkanoic acids. So an acid test is very simply carbonate. All right, we put some carbonate, bicarb soda, calcium carbonate, sodium carbonate, whatever carbonate, and it will bubble. Give us nice little bubbles, and we know it's an alkanoic acid. Now, alcohols and alkanoic acids form esters. So these things smell, and they smell nice. Okay, they smell nice. There's some of these organic chemicals really stink. Some of the acids really stink. Butyric acid smells like rotten cheese. It's terrible stuff. Esters smell nice. And we can also test for them by saponification. Okay, so whether they make a soap. All right, so that's the two tests for them. Don't forget also to make esters, it's an alcohol, and your carboxylic acid, or your alkanoic acid. Okay, so those two mixed together give you your ester. Aldehydes. All right, remember our primary alcohols, when they oxidize, the first thing they make is the aldehyde, and we've got that double bond oxygen group there. Okay, now don't forget, they will then oxidize to the alkanoic acid as well. So there's two steps to a primary alcohol oxidation, whereas with an ketone or an alkanone, there's only one step for a secondary alcohol when they oxidize, and that is to a ketone. Okay, and we have, that should be a double bond. I don't know why that wasn't very clear. That's a double bond oxygen there. But you can see how it's on, there's carbons either side of that carbon, whereas up here there's not. Amines, amides, don't worry about them, just worry about the amino acids, okay? But I'll do a separate PowerPoint slide for those. So what you need to know is the tests for these. What tests do we use, and what are the positive results for those tests, okay? Be great if you could learn all these functional groups. But you don't have 2 months to do that. So make sure this page here is sticky noted, okay? All right, so we're going to have a look at the oxidation of alcohols, okay? And I'm going to look at just the primary. I'll do the secondary on the next slide. And we're going to look at ethanol bipermanganate. Okay, so I know my primary alcohol oxidizes to aldehyde, and then to an alkanoic acid. All right. So what I'm going to do is I'm going to do the complete balanced equation of the primary going to the alkanoic acid. What I will do is I'll write down the whole thing here, but I'm only going to look at that and oxidized with the permanganate when I balance my equation. Okay, so I start off with, okay, so let me draw the structure of ethanol. And I've got 3 carbons there, and 1, 2, 3, 2 here. So we have C2H5OH, and I'm forming an aldehyde, so I've got a double bond oxygen, and I've got 1 carbon there, so I'm, what's that, C2H4O. Okay, so I've got 2 carbons here, 6 hydrogens, 1 oxygen, 2 carbons here, 4 hydrogen, 1 oxygen. Alright, so I can see that I'm 2 hydrogens short. So I need to add 2 hydrogens here. And now because I've got 2 plus, I need to balance out the pluses, so I need to put 2 electrons as well. Now that would be my half reaction for the aldehyde. Okay, but we're actually going all the way, so I should have drawn that arrow from here actually, to the alkanoic acid. Let me just draw that, and let me go through and put my hydrogens. Okay, so that is C2, 1, 2, 3, 4, O2. So if I quickly do that again, I've got 2 carbons, 4 hydrogens, and 2 oxygens. Alright, now if I compare that to over here, I'm short that, and I'm short one of those. So I'd actually have to add 2 hydrogens, and if I add 2 hydrogens, I've got to add 2 electrons. And I have to add water over here. And now that I've added that water, I have to add 2 hydrogens short over here, so I have to make that a 4 and that a 4. Okay, a little bit different to if we went this way here. So if I did the oxidation from here, I'd have to add water, and I'd have to, and because I've got 2 hydrogens here already, and I've added 4, we would cancel that out to 2. So I think that's where I got a little bit confused in class the other day. So let's just ignore this and let's just focus on this one here for the moment. Okay, so the alcohol going directly to the alkanoic acid. Now page 446 gives me the half reaction from permanganate, MnO4 minus plus 8H plus 8 electron. Oh no, it's not, that's 5 electrons. 5 electrons gives the manganate, manganese, and water. Okay, so I've got my half reaction for the alcohol. Let me write that down here. C5OH plus water gives me my alkanoic acid and my hydrogens and electrons. Alrighty, so let's have a look here. I got 4, I got 5. Okay, so the common number here is going to be 20. Okay, so I'm going to have to multiply this whole thing by 4 and this whole thing here by 5. Okay, so if I join them together then, we have some big numbers, but that's all right. 5 of the alcohols. That's going to give me 4 of the manganese, 16 waters, 5 of the alkanoic acids, 20 hydrogens, empty electrons. Alright, let me change colors here. Okay, first thing I do is get rid of the electrons. Cancel out. Now I want to get rid of the hydrogens. 32 here, 20 there, so I can get rid of them. And I'm left with 12. Waters, 5 and 16, and get rid of them, and I'm left with 11. So that then would be my complete balanced equation. Okay, so that's for the primary alcohol. What I might do in class on Friday and Thursday is just have a look at, or next week, is just have a look at the aldehyde to just this one here, the aldehyde to the alkanoic acid. That looks very confusing now I look at it. Hopefully it hasn't confused you. Alright, so let's have a look at secondary alcohol now. So we've got 2-propanol reacting with dichromate. So if I write down the structure for propanol, meth, eth, prop, it's 2. So I know my OH group is coming off that carbon there. Let's put all the rest of the hydrogens in. One more there. So we've got C3H8O. And because it's a secondary alcohols go to ketones. Okay, so what I want to do is put a double bond oxygen where that OH group was. And we do the same thing. Out of all the hydrogens, there's not going to be one here because I've already got 4 bonds around that carbon. So we've got C3H6O. So straight away I can see I am 2 hydrogens short. So I need to add those 2 hydrogens in and then the 2 electrons. Okay. Now the beauty of this one is for every secondary alcohol, it's going to be the same. Okay, so it doesn't matter what your chemical formula is here. Whatever the alcohol is, it's always going to be 2 less hydrogens, so that you have to add 2 hydrogens here, 2 electrons, no matter what the secondary alcohol. So that's kind of good for us. We don't need to remember too much. Alright, and then all I need to do now is write out the oxidation half reaction for the dichromate. So page 446, if you can't remember it, and we've got dichromate. Okay, so all we do is we just write out the half reaction for that, and 2 chromium 3 plus 7 water. Alright, so let's compare the electrons. 2 on this, 6 on this one. So I need to multiply all of this by 3. Okay, and then let's put them all together. Okay, so my chromate stays the same. And that gives me 3 of those. So now I've got 6 hydrogens, 6 electrons, plus the chromate 3 plus the water. Alright. So last thing we do is we cancel the things out. So I always cancel out the electrons first. Okay, because they should be balanced. That's what we did up here. By multiplying that by 3, we're balancing those electrons. Then let's have a look at the hydrogen. We've got 6 here, we can get rid of them. That leaves us 8. And there's no water on the side. So there's my final balanced equation. In its simplest form. Okay. And That would give me an A. Isn't that fantastic? Alright, really quick recap here. So you guys need to know the structures. Okay. Page 441 for that. So make sure they have that sticky noted. You need to know the tests for the different ones. So what's the test for an alcohol? That's your sodium test. Don't forget you need to dry it first, make sure there's no water there, and we can use calcium chloride for that or something else. Alright, alcohols, what's next? Let's go back to alkenes. So remember they have a double bond, so they are very reactive. And we can use any halogen, so something like bromine, fluorine, chlorine. Okay, that will break that double bond and it will form, well, whatever we have, the bromine or the fluorine or the chlorine will bond to the carbon in place of that double bond. What else do we have? We have alkanoic acids. Okay, very simple. Test for that is carbonate. Bicarb soda, anything like that. Gives off a gas, it's an alkanoic acid. Gives off carbon dioxide gas. Esters. Test for ester is the smell or saponification. Okay, so we react it with a base and it makes a soap, a triglyceride. Don't forget, esters are formed from alcohols and alkanoic acids, and they are named from the alcohol, for instance methyl, and then the alkanoic acid comes first. So for example, butanoate. Okay, so if I have the ester methyl butanoate, this is my alcohol, methanol. This is my alkanoic acid, butanoic acid. That's how it would be formed. Okay. Let's change the color here. It's starting to get messy, isn't it? Aldehydes. Aldehydes. Okay. So they are primary alcohols that have been oxidized. And they have that double bond oxygen on the end of the carbon chain. Okay, whereas ketones are from your secondary alcohols that have been oxidized, and they're like in your middle carbon. So you've got a couple of carbons either side. Okay, and also don't forget your tertiary alcohols. The test for these is just your oxidation. Okay, so remember your tertiary one won't oxidize. Okay, and lastly, that's it. Okay, don't worry too much about the amines, amides. The amino acids we'll cover separately. So that's your organic chemicals. Oh, I will do one more slide actually on naming. Alright, so let's go through naming organic compounds. So we start off by the number of carbon atoms. Okay, so let's go up to 10, 8, 9, 10. So we go meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. Okay, so this is our prefix. And our suffix depends on what it is. So if it's an alcohol, we use anol. If it's aldehyde, anal. If it's alkanoic acid, we use anoic. What else have we got? Esters. We use anoate. Ketones. We use anone. And that's about it, I think. Okay. Alright, so we name a compound based on the number of carbons. Okay, so a 5 carbon unit is going to be pent. Now let's say I had an alcohol group here. Okay, I need to write what carbon it is on. So we go by the shortest way. So this is 1, 2. So this would be 2-pentanol. Alright. Now if I had the same thing, but let's say I had a methyl group here. Okay, same thing. We number from the alcohol group first, the functional group. So this is the longest chain is still 5. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So there's always going to be 5 carbons in this one. That's our longest chain. So this is going to be still 2-pentanol. And I can see I've got a methyl on the 4th carbon. Now it doesn't matter if it's this methyl group or that methyl group. They're both on the 4th carbon. So I would do 4-methyl 2-pentanol. Okay, now let's complicate that a little bit. So let me do my 5 carbon pentanol, but this time let's have 2 carbons coming off this. Alright, so I'm still going to number it this way. Alright, now instead of that being the 5th one, look at this, I've now got 6. So this is no longer pentanol, this is now hexanol. Still the 2 on the 2nd carbon. And now I have to have a look over here. What have I got? It's on the 4th carbon and it's a methyl. So this is now 4-methyl 2-hexanol. So the important thing is find that longest chain that you can. Okay? And that is your prefix there. You look for the functional group. That's your suffix. And you count the shortest way to that functional group. That's where you start counting your carbons from. Okay, so I'm not going to go 1, 2, 3-methyl 5-hexanol. So I always do the shortest way to my functional group. Alright, so I hope that helps you out.